Hello again, YouTube. The last time I left it, I'd implemented a test of MODBUS protocol, master slave, over a serial interface between two cinnamon buns. So I said at the time, at the end of that video, that it was a bad idea to do that, because I've implemented both the master and the slave. I'm testing my code against my code, or my implementation of MODBUS against my implementation of MODBUS. So if I've done something wrong, even though the two will communicate, they're not communicating to the standard as specified. So I said that I would have to get a different master and a different slave to test my master implementation against somebody else's, my MODBUS implementation of a master against somebody else's implementation of a slave or MODBUS, and vice versa. So moving the cinnamon bun aside for a moment, I managed to get my hands on a cheap MODBUS RTU. This is temperature minus 20 to 80 degrees and a relative humidity in percent off eBay, and it's just a simple 4-pin connector that is, I have the power already connected to the connector. So the connections are ground, VCC, B and A. So those are the RS485 physical interface. So we've done MODBUS over 232 or serial. Now we're going to do it using this over the RS485 physical layer. And the DC input voltage is from 8 to 24, so it's fairly it's fairly easy to find something to plug into that and get it working. Now the documentation with that is in a foreign language, but the numbers make sense. So it's baud rate from 1200 up to 19K2, as we'd expect, sort of that kind of, and I think the standard says 9600 is the default, but we'll check. Now this, according to this documentation, this is, given that this is a MODBUS frame, the slave is address 1 and it's accepting command 3, which is the read registers command in the MODBUS specification. So the last time I messed about with the command 01, which was read coils, which is read bits. It's a bit field that you read back where something is on and off. So this is read register, and a register in the MODBUS standard is a 16-bit value. So slave 1, read registers. This is the address of the register we want to read, which is 0, and this is the number of registers that we want to read, which is 2 registers, and then the CRC. So this is the frame that this sensor is expecting, and its response, if I'm reading this correctly, is coming back from slave 1. This is a response from slave 1. It's a response to the read registers command. There are 4 bytes of data following, and the temperature is in the first 16-bit value, and then the humidity, the relative humidity, is in the second. So that's fairly easy. There's a further bit on down about changing the address. If you were on a MODBUS bus, RS485 bus, with a number of different slaves, then you may have to have an address collision, so you'd have to change the address so it didn't collide with something. But that is the basics of what we want to send to this slave. So for a master, I got, for very little investment on my part, this serial USB to RS485 device, and inside this there's just going to be another transceiver, the same way as on the expansion board for the cinnamon bun. There is an RS485 transceiver chip. There will be another RS485 transceiver chip in here. So this is is going to act as my, well, not so much as my master, but like the interface, the actual, if I plug these wires in, So if I just plug this in, that powers up. There's a LED. So now when I plug this dongle into my Linux laptop, it's attached as a serial, the same way as when I connect my USB, the FTDI Raspberry Pi debug cable. It comes in as a serial USB, TTY USB. So this is my device, and to get somebody else's implementation, I've installed libmodbus from Git. So if I bring up my main.c, which I've written just a piece of code to test this out, I have the instructions on the top there. Just basically clone and install this library. Now I do have to change the library path, add to my library path, so that the system knows where to get libraries from, and then it's just a case of compiling and linking against that library. And the code is just this is a very small piece of code to basically write that message to read the registers from this sensor. So basically all I'm doing is setting up that device dev TTY USB 0, 9600, no parity, 8 data bits, 1 stop bit, and the rest of these commands I've set debug to true just so we can see the messages that are being passed. And this is the slave. I'm not setting slave mode, I'm setting the slave that if you were in slave mode, then this was what the slave number that you would be implementing if you were implementing a slave. This is implementing a master because we're sending out a request to read registers. So we're going to be reading the registers from this slave that we've set in set slave. And the rest of that is pretty straightforward. I mean, the documentation is there in libmodbus. We then connect to our Modbus device, and like I say, I'm executing the command that temperature humidity sensor is expecting. I'm saying I want to read register 0 at address 0, and I want to read 2 registers, and the response is going to be placed in this buffer of 16-bit values. Now I've made an array of 10, but I'm only going to be reading back 2 16-bit values, 4 bytes, and given the return values, I'm just going to take the first 16-bit value, divide it by 10, because the sensor is transmitting the values as tenths of a degree and tenths of the humidity percentage, according to that sheet of paper. So if I now execute a.out, sorry, you can see I'm sending what the sensor expects. So I want to read from slave 1, read holding registers, which is command 3, and then the address is 00, the register I want to read, and I want to read 2 registers. Now I said that my implementation, when I tested my implementation against my implementation, it would work, but that didn't necessarily mean it was compliant with the standard. My implementation reversed these 2 bytes of the CRC. So I was doing, it's basically a big Endian, little Endian problem. So the most significant byte first or the least significant byte first, and I had reversed it. So my implementation would not speak to either a master or a slave device that was implementing the Modbus standard, because I've misread the standard. But that's a simple case of then plugging in a device which does, and recognizing that you've got the CRC the wrong way around and changing the order you insert those bytes into the message. So the frame comes back from the slave, and we've got a response from slave 1. It's a response to the read registers, and there's 4 bytes to follow, and there are the 4 bytes of data. So we've got BB 00BB 0274, and the temperature is BB, and that's, when you divide by 10, that's 18.7 degrees, and likewise the humidity is 62.7999%. And if I do this again, humidity has gone, temperature's gone down, and humidity's gone up. And that's we've got a master talking to a slave. Now this is somebody else's implementation. Our master is running libmodbus, which is available on GitHub, and our slave is this embedded sensor, which I've managed to get off eBay. So if I now dismantle that and plug in to test my implementation of Modbus, which is in the libe soup, library. If I just get this. So now I have got the A and B coming from the USB dongle into the A and B of my RS485. So now I'm going to be transmitting a Modbus master connected to my implementation of a slave and executing the same thing. Now if I stick in a programming interface and the PicKit 3 and power to my cinnamon bun, and this is my previous implementation of the slave, and I only previously processed Modbus read coils, which is the command 1. Now this is looking for command 3, which is read holding registers. Now I've hash defined this out for the minute so that when I receive that frame, I'm going to respond with an error frame that says that function isn't recognized by this device. So if this gets programmed up, then if we execute now connected to my cinnamon bun, my response to the same message is coming back from slave 1, but we've set the highest bit. So we transmitted read registers, and the response has been read registers with the top bit set, so it's an error. And the error code is 1, which is an illegal function. So we can see that my implementation at least is giving us errors. If I put that in and actually process that message, so we're going to process read holding registers, and I'm going to call this function up above, and all I'm doing after checks is loading up the registers with the 4 bytes I'm going to send back, which is 00B70279, just as an example. So now I execute the same command, and now my response is the 4 bytes that I expected. So 00B70279, which is what we loaded up the buffer with. 00B70279. and that works out at a temperature of 18.2 degrees and a relative humidity of 63.29. So that's my implementation. Given that I've now corrected the order I put the CRC, the Endianness of my CRC bytes, I now have a master, or my slave implementation, my Modbus implementation, the slave side, is working with libModBus. So I'm happier with my implementation. It's not fully tested. I mean, my implementation of Modbus, at the minute, I'm only processing in this slave. I only have the code for read coils and now read holding registers. But there are far more commands in the Modbus standard. So if you needed that functionality, you just have to add those into the code. This is just an example to show a protocol in use. So given that we've tested my slave implementation of Modbus with what I believe to be a good master implementation of Modbus, because it's this libModBus library available on GitHub, I'm now going to test my master with a slave, which is that slave that the temperature humidity sensor. So if I now, I may have to pause here and connect things up. So now I've connected up, I can hopefully program this master into the device, and I've plugged in my debug, the FTDI Raspberry Pi debug cable, so I can see the output of this, and there is the basically AB. I've got a pull up and a pull down because I was getting a bit of mains noise on this sensor, so AB connected into our slave device. So this is now acting as a master, and all it's doing is, previously we had a timer, and once it expired we sent out the once it expired we used to send out read coils, which was my implementation of my own master, my own slave. So now I've written the new API function for the library, read holding registers. So if I look at the time, every 30 seconds we're just going to send out the read holding registers request, and my API is asynchronous. So the libModBus, that when it was running on the Linux, it was synchronous. When I executed the command, the message was sent and the response was received, and then the function returned. Whereas this is asynchronous. I want it'll return immediately, but when it gets an answer to the question or the response to the message, call this register's callback, and all it does is print the message in its entirety, the whole message, unless there's an error. Well, it prints the message, and then if there's an error it adds error response on the end. So all my code is going to do is every 30 seconds, and you can see that this is the response I'm receiving from that temperature humidity sensor. I don't know what I could do to get it to change. Let's see. Yeah. So there's the temperature, 0B. I haven't got that to change, but I just held my hand over it and I got the humidity to change. So that's it. I'm going to leave Modbus there. I've no need to add more functionality. It's only a skeleton, the libModBus that I've implemented in libsoup library is only a skeleton of the libmodbus standard, but I only implemented it to show a very simple protocol working over. We've done Modbus over serial, which I suppose you could call 232, RS232, and we've done Modbus now over RS485. The 232 and the 485 are just physical layers where characters are being sent. Modbus actually defines the messages, or the format of the messages which are sent. So we know that this is slave 1, read registers, and there are 4 bytes following. BD is the temperature, and 29C is the humidity, is the relative humidity. And happy enough with that, so I'll leave that there and move on to other more interesting protocols rather than Modbus. Now Modbus is still used extensively in the industrial automation, so for plant, for measuring temperatures, for outputting devices, turning heaters on, turning air conditioning on, coolers, pressure sensors, it's used extensively. So whilst it's not the most advanced protocol in the world, it's quite simple, it's still used extensively. But that's where I'll leave it for the minute. Thanks a million for watching, and I hope it was of use to somebody.